Today I'm going to talk about a problem from the book that first gave me a lot of trouble, but if you take it one step at a time, it's not that bad. So I'm going to skip reading the question, it takes too long. So first we're going to draw a diagram here of all the values we're given, and we've got a mass of 95 kilograms, a 1y value of 45 meters, one of 4 meters, and you can get that if you take the 41 meters that he'll fall out of the 45 meters he starts from, and we got 4 meters here. We can also write down our given values. It tells us that the cord is 30 meters long, and that means that the equilibrium is going to be 30 meters down. We have a mass of 95, two y values here, and this can tell you that we're going to use conservation of energy, which states that energy cannot be created or destroyed. So from point A to point B, it might be distributed differently, but our potential and kinetic energy are going to equal the same magnitude. So we have our displacement of x also, and this is taken from the 30 meters long, which it's at equilibrium. The 41 meters he'll fall, so there's a difference there of 11 meters that the cord will stretch, and we have a force on the spring of 380 newtons, and so we can plug that into our conservation equation. We have kinetic energy here, potential energy here. We also have a potential energy for our spring here in the final state. In the initial state, it's really not part of what's going on. So we can plug all those values in and see that we're missing K, and that's perfect because the question's asking for a displacement value X, and we don't have that. We can't get that from the conservation of energy equation. So what we need to do after we solve for K here, which gives us 631 kilograms per second squared, is we can put that into Hooke's law. And Hooke's law states that given a force of whatever magnitude, there's going to be a force equal and opposite, pulling it right back to equilibrium. So we have 380 newtons. We can divide 631 kilograms per second squared into that, and we'll come out with, we're missing a number, x equals 0.602, and there we go.